Okay, so we're back here looking at our console log example, and we're going to use this opportunity to talk a little bit about data types. So data types uh, essentially describes the sort of types of language, the pieces of language that a computer understands by default, right? So we can liken this very easily to the sort of parts of speech that we think of in English or another spoken language, right? We understand the concept a noun is a thing, a verb is an action, subject, object, things like that, right? So we have this, we can think of the constructs, we can think of the data types in programming languages to be very similar to particularly things like nouns, verbs, adjectives, these basic parts of speech from which all of the complexity and interesting concepts of language and of programming are constructed. So we're going to start with the basics here, which I think should probably be pretty straightforward for you guys. So one thing that we have the option for is we have numbers. Now the thing about a computer is that you kind of always have to, every time you tell it that you want it to remember something, you have to say, hey, I want you to remember this. And so a very common concept that we talk about with programming languages is the variable. What does a variable mean? A variable you can think of like a box with a name, right? So we indicate to our computer that we want it to keep track of something, right? I could just start, typing numbers into my code, but that's not really going to do anything because in order for it to do work on a particular piece of information, I have to tell it to keep track of it, right? It's a little bit like when we try to remember a phone number by repeating it in our head or writing it down, right? When we declare a variable, it's like saying to the computer, hey, write this down in your notebook. I want you to keep this handy for easy reference, right? So in order to tell the computer that we'd like it to set aside a box for information, we use a keyword called var, okay? V-A-R, short for variable. And it's all well and good to set aside a box, but if we don't have a name for that box, then we don't have any way to tell the computer which box of information we're talking about later. So we're going to create a variable, and I'm just going to call this some number. Now, I want to, again, point out a couple of things about this. I've used my keyword var, okay, and that says, hey, create a box in memory, right? So choose a place that you're going to put this stuff and label it some number. Now, as you can see from this, right, I can actually call my variable anything that I want. It's just a label. So as long as it follows the same conventions that we talked about the other week in terms of naming, right? We can use numbers if we want. We don't want to use things like quotation marks, slashes, plus signs, anything that's unusual, spaces, certainly a no-no. And you can see that I have used the same kind of convention I mentioned, where I tend to start with a lowercase letter and then all the subsequent words. I like to make them descriptive. It's helpful to make your variables descriptive because then you know what they contain, right? If you have a jar of flour in your cupboard, you're probably going to write flour on it. So in this case, it's a pretty generic box that I want it to create. So I'm just going to call it some number. Now, the question is, if I create this box, but I haven't put anything into it yet, what does a computer think is in there? And I can find this out by using my console log statement again. And I want to, again, point out a couple features about console log. So the first time I use this console log function, or method we sometimes call it, right? And a function is basically a set of instructions that we give to the computer. We can create our own functions, particular steps, processes that we want the computer to follow. There are certain ones that are built in, again, right? Things that the computer has sort of already learned. It's already been taught by its basic underlying programming, right? We're always programming on top of other programming. So, for example, if you are learning to play the piano, you may not know how to play, I don't know, Pachelbel's canon, right? But you know how to push down a key. So when we talk about learning to play the piano, you might need instructions on how to play a particular piece. You do that by reading music, but you don't need really detailed instructions like how do you apply your finger to a particular key and press it down. So console log is one of these built-in things. It's something that the computer already knows how to do. So right? So in this case, what I have on top is text, right? It's just a string, a quotation. It appears in quotation marks, and it's going to print out in exactly that way. Now, I've created a box in memory and labeled it some number, and now I'm going to say, well, hey, what's in the box? So this is a nice test to sort of see how our computer treats this situation. So again, I've come back to my web page. Just by reloading it, it's going to execute those console log statements. That's those scripting statements. And I can see that my first statement comes out, and the second one comes out as undefined. So undefined is the value that a box contains, or I would say it's the value, that a box has before anything has been put inside it. Okay? Something else that I'm doing here that you may notice, what are these things that are popping up in gray? One of the great things about code is it kind of lets us annotate, and we call it, or comment along the way. So in JavaScript, when I want to tell the computer, hey, listen, this stuff that I'm writing is just for me. It's just for the programmer. I want to understand what's happening here. But I don't want you to try to interpret this as part of the script that I'm writing. I just want to have it there for my own reference. So I use 2 forward slashes, and you can see that one of the nice things about Aptana is that it's using visual cues. It's using color coding to show me how it understands what type of information it thinks various pieces of my code are. So we see that log and var are this kind of pale yellow, and that's because it understands those things to be keywords, right? To be special functions that the computer has a known meaning for. If something is green, it means that it is a string or a piece of text. If it's sort of dark gray like this, then it means that it's a comment, right? It's something that the computer is going to ignore. Also, again, to point out that this semicolon, right, our sentence ender when we're talking about code. So this is a really nice way. Commenting is going to be really, really important in our process this term, because basically what it does is it lets us interpret in English, or our language of choice, to describe what's happening. It's really, really easy to forget what your code does. So commenting is a really important process, both for yourself for reference and for sort of understanding what you're doing, and also when you're working with other people so that they can see what you're trying to do and find out if it works well for them. So we have this undefined thing. Now, remember that some number is a variable. So what does it mean to say that something's a variable? Well, it means exactly that. It means that its value can vary, right? Its value is the thing that is put in that box. So for example, right, I can say some number equals 3, right? The equal sign is what we call assignment. Equal sign says, put the thing on the right-hand side into the box that's labeled with the label on the left. So in this case, I'm saying, hey, that box that's labeled some number, I want it to contain the value 3. And again, if I were to use this same console log statement, right, and print out some number, what do we think is going to happen? Let's find out. There we go. So by putting that equal sign and the 3 on the right-hand side, right, I'm saying, hey, these two things are equivalent. The box that's labeled some number, I want it to contain the value 3 now. I could change this, right? I could then later on, and this is an important thing to note as well, computers read the same way that we do in English, top to bottom, left to right. So if something happens after something else, it's going to change it. So I can now go ahead, again, console log some number. First time it was 3, the numeral. Second time it was 3, it's 3 text. So how do we do here? Right? Okay, so this is just to show you guys the basic concept of a variable. A variable is kind of like a box or a container. We give it a label so that the computer can find it. It's something that we're telling it to set aside, write down, remember, because we want to be able to access it later. This is a really powerful concept because what it means is that we can sort of keep track of and change things over time throughout our program. So we've already encountered two basic data types. Okay, our 3 here is a digit. We're pretty familiar with this concept, right? It's a number. I can do math with it. So I could do something like console log some number, right? So when I use that some number, what the computer does when it goes through the code is it takes the most recent value, in this case 3. At the moment that I write this console log, the value in the box labeled some number is 3 because that's the last thing that I told it to put in there. So I can do this, right? / divided by 2. Let's see what happens. 1.5, pretty much what we'd expect. Now, here's a tricky thing. What if I set some number equal to 3, but I put that 3 in quotations? Now what's going to happen? I'm going to console log some number divided by 2. Save my changes. Very interesting. So what's going on here? It looked like a string. Would that work if I put in the text 3? Not so much. I get this code NaN. So what's going on here? Even though when I had this numeral 3 in quotation marks, JavaScript is what we call a weakly typed language. Basically what it's going to do is it's going to make a guess for you. It's going to say, look, I know that you put quotation marks around that digit, right? And that you're telling me you want it to be a string. But hey, right here, you're trying to do math with that string. So I'm going to check it and I'm going to see if it contains a numeral. And if it is, I'm going to bet that you want it treated like a number, right? So that's what we got the first time around. Even though we had set this to a string, we had called it a string by wrapping it in quotations, it said, you're trying to do math with it, probably you want me to think about it like a number. By contrast, when I put in the text, not so easy. It's going to give me this NaN. NaN is a special code, kind of like undefined, is like a special word for describing an empty bit of memory, an empty box, if you will. NaN stands for not a number. Oops, that's interesting. Doesn't want me to label it there. So here we have an interesting thing where my code is confused because there's a slash in here. And so that's why it's messing up my commenting. So we'll just go ahead and put this in here and say next line returns shows not a number. So what we're doing with that not a number, or what that not a number is indicating, is basically that the thing that we're trying to do, math on, isn't a number. And so it's giving us what we would think of as an error message. So in the next segment, we're going to talk about a few more data types that are going to be really powerful for us to use. Specifically, we'll go to Booleans, arrays, or lists, and objects, and take a look at how those behave and how those interact with our console log, so we can get a sense of what's going on behind the scenes in our program by printing it out to the console window.